This is higher homework. It's practice paper B. It's the non-calculator paper, and we're going to go for question 23. Okay, so this is looks like an addition formula type question that I've got here. And what I'm going to do first of all is I'm going to try and solve this by making it all equal to 0. So I'm going to get the 5 cosine x over onto the left hand side. So I've got 2 sine 2x minus 5 cosine x equals 0. Then what I'm going to be looking at is this part here, and I'm going to look at my formula sheet, and what I'm going to do is I'm going to substitute in there what I have for sine 2x. So I've got 2 sitting outside, and what I'm going to substitute in is 2 sine x cos x. Okay? That's minus 5 cosine x equals 0 sitting there. I'll multiply this bracket out, okay? Right, so looking at this here, I'm going to try and factorise this out now, and what I can see, I've got the common factor between both sides would be the cosine x. So let's get that out as a common factor. And that would just leave me with 5 at this side here, and that equals 0. Okay, from there I've got 2 possible solutions that are going to come out. So from here I've got cosine x equals 0, and from inside the bracket I've got 4 sine x minus 5 equals 0. So here I should have sine x is equal to, take the 5 over, positive 5, divide it by the 4, there's the 4. Okay, so on this side over here, what I should have is that x is going to be equal to the inverse cosine of 0. And now what I can do there is I can think about the cosine graph, and the cosine graph would just be something looking like that. I know where it's equal to 0 is going to be there, and these values there I know are 90 degrees and 270 degrees. If I look up at the range that I'm working with, I'm working in radians. Okay, so I need to put my answer in radians. So from here what I'd say is that x is equal to, so 90 degrees is pi upon 2, and also 3 pi upon 2 for the 270 degrees. Okay. Right, over to this side to look for my solutions. Well, I know that the maximum of the sine graph or the cosine graph go up to 1. So if I look at that kind of graphically, I've got a sine graph, goes up to 1 here, goes down to minus 1. I'm trying to look for a solution up here somewhere, and there's no solution in there because it doesn't touch the graph at all. So what I've got here is no solution from this side here. So just to tidy it up, the solutions are x is equal to pi over 2 and 3 pi over 2 radians, because I've been asked to do it in radians. You can do the work through in degrees and then change it to radians at the end. That would still get you the marks for this question. Let's see where we're going to gain the 5 marks. Okay, so first thing I'm going to get is for substituting in here. So substituting in for the sine 2x. I'll take a mark here for this line here. I want to make sure it says 0 equals 0 on the right hand side all the way down, and I've factorised out from there. I'll go for a mark for this part here. Okay, and let's see, I'll go for a mark for this bit here as well. So I'm going to look at all of this for 1 mark, and I want you to make sure that you've said that there's no solution to this side here. So as long as I can see that there, either there or down here somewhere. Finally, just for stating the solutions, the correct solutions there. So that'd be 1, 2, 3, 4, 5. 5 marks out of 5.